Okay, so this is going to be a video going through the answers for the chemistry quiz. You will get a copy of the answers, so I will do a hard copy and scan it. However, it might be useful if you're a bit unsure about some of the questions to actually watch me work through the process. Now, I actually already started this, as you can see. The reason being that I thought I could pause the video and then restart it, but turns out I can't. So I'm going to whiz through some of them once I've explained the basic process. So that's what I'll have to do, but you'll have to just watch me do it. So I'm going to go back and explain what I just did here. So here we needed to do number of protons, electrons, neutrons, number of valence electrons, and number of electron-containing shells. We get all that information from the periodic table. If we look at our periodic table, we can see that for sodium, which is the first one, and we've got a little key up here, atomic number is the number of protons, and it's also the number of electrons, because the positives and negatives in an atom will be equal. To work out the neutrons, you take the relative atomic mass, you round it up, and then you subtract the atomic number from it. So for sodium, 11 protons, 11 electrons, and then relative atomic mass, 22.99 rounded up to 23, minus the atomic number, which is 11, equals 12. So you can see here 11, 11, and then 12. Now to work out valence electrons, that's electrons in the outer shell, we simply look at the group that the element is in. So group 1, there is 1 electron in the outer shell, 2 is 2, we skip this section, 3 is 3, 4, 5, 6, 7, 8. Obviously helium only has 2, but it's still classified as full because it's the first shell. So sodium is in group 1, that means it has 1 electron in the outer shell. Correct. Now, number of electron-containing shells, that equates to the period or the row. So across here, period 1, that would have 1 shell with electrons in it. Period 2 would have 2. Period 3 would have 3. So sodium is in period 3, which means it has 3 shells that contain electrons. Correct. I'm going to fill in the rest. So number of protons would be based on the atomic number, which I would have got straight from the periodic table. The electrons will be exactly the same. The neutrons, I'll have rounded up the relative atomic mass and subtracted the atomic number, so they won't necessarily be the same, although you can see that sulfur was the same. Then I use the group number to determine the number of valence electrons in the outer shell. And then the number of electron-containing shells is the period or the row. Okay, second question was we had to draw an atom of phosphorus. So we had to include the number of protons, neutrons, and number of electrons and show the correct location of these subatomic particles. I might actually, right, so we draw the, sorry, this is going to be not the best drawing because I've got my phone in my way. So we're going to draw the nucleus, and inside the nucleus, so we know that phosphorus has an atomic number of 15, so that means 15 protons. It will also have 15 electrons. And in terms of neutrons, the relative atomic mass is 30.97, so that's 31 minus 15 is 16 neutrons. So in our nucleus, I might put P for phosphorus, I'll put my 15 protons and my 16 neutrons. So I've got 15 electrons. Now I could go, okay, I'm in group 5, so that means I have 5 electrons in the outer shell, and I'm in period 3, which means I have 3 electron-containing shells, so that could be my shortcut. So I know I've got 3 shells. First shell, so that's the nucleus, so that's not a shell. First shell, 2 electrons. Now to make my drawing life and counting life easy, second shell is 8 electrons, so that's a total of 10. And I know I have 5 in the outer shell because of the group, but 2, 8, 5 equals 15, 15 electrons in total. There you go. All right, now an ion. Now I do want to actually probably do a little bit of an update in your notes. So an ion is a charged atom or molecule. Now you could mention, although I haven't actually asked for this, the reason it's charged is it's charged due to the loss or gain of electrons. That wasn't required for this answer, but that's actually why it is charged. Now the name of a positive ion is a cation. The name of a negative ion is an anion. My dogs. Alright, now these were hit and miss. Oh, not really actually. But what I ended up expecting was a little less than what I had initially expected you to put in this answer. But I'm going to give you an example of what would be a perfect answer in terms of everything complete. So, magnesium. So let's have a look where magnesium is. Magnesium is in group 2. So you might, in working out this, you would need to know that magnesium is in group 2, which means it has 2 electrons in the outer shell. Right. So we know that in forming the ions, we either lose or gain electrons to have a stable outer shell. So magnesium is a cation with a 2+ charge, i.e. it's good to write it like that. Now explain why it forms that. So to achieve a stable outer shell, magnesium loses its 2 outer or valence electrons. This is the bit that I sort of wasn't, I didn't end up expecting, and I also didn't expect that bit for full marks, but in the perfect answer I would. So this results in an excess of 2 protons, which are positively charged. Therefore, an overall 2+ charge. Okay, so most people put that it was a cation or a positively charged ion, and the reason why is because it lost 2 outer valence electrons to get a stable outer shell. So I ended up going, well, that's enough because you've technically explained that it is a positive ion as opposed to a 2+ positive ion. But you can see that the rest of the answer really clarifies why it happens that way. In terms of the next one, I'm actually going to write it out later because otherwise I'll be on this video forever. But essentially, this one is fluorine, and that has 7 electrons in the outer shell. So it's going to become, fluorine is going to become an anion with a 1- charge, i.e. F- or F1- if you write it that way. And then you would explain the same thing. To achieve a stable outer shell, fluorine gains one extra electron. This results in an excess of 1 electron, which is negatively charged, therefore an overall 1- charge. So that's what you'll write in this next bit, which I'll do later. All right, moving on to sodium and chlorine combining. So in this one, I think I might just show you this and draw it in later. So you can see here you needed to draw the sodium atom. Now you didn't need to worry about protons and neutrons in the middle. 2 electrons in the first shell, 8 in the second, and 1 in the third. And then chlorine is 2, 8, 7. And then you just had to show that this 1 valence electron was transferred over to the outer shell of the chlorine atom to give it a full outer shell of 8. And by removing that electron, you've now just got a full outer shell in the second shell. It was important that you didn't have that electron still there and put another one here. So you had to show that some way by crossing out 1 and adding 1, or just leaving that one there and putting an arrow to say that it would go to there without actually drawing it in. So don't have extra electrons in your drawing. And you needed to show that this is the direction of the movement. You can see that by donating, oh sorry, the pen doesn't want to focus. By donating that 1 electron, you become a 1+ ion, and then chlorine, by accepting, becomes a 1- ion, and then those 2 ions are attracted in a 1-to-1 ratio to form sodium chloride. Okay, I'll draw that in later in my proper answer. Okay, so all you had to do for your chemical names is use your valency table, which I'll pull up now. Okay, so valency table. So for example, you've got Na2CO3. So you know that Na is sodium. So you'd write that part first. And then CO3, if you look here, is carbonate. Carbonate. No need to write and or plus, you're writing the name of a chemical. And the chemical is bonded, so those 2 parts are bonded together, so no need to put plus or and. No need to specify numbers. Same thing applies here. Magnesium, OH is hydroxide. NaCl is sodium. Now just remember, when you're doing ionic compounds, if you've got these what we call molecule ions or polyatomic ions, so they are ions being a charged molecule that are made up of multiple atoms bonded together of different elements. So CO3, or carbon and oxygen, are bonded together and they have an overall charge of 2-. In hydroxide, oxygen and hydrogen are bonded together and they have an overall 1- charge. When you've got a situation where you've just got an element, when it's an ionic compound, the first part of the ionic compound name is just the metal, so the name, so sodium. Down here it's barium. However, we take the second part of the name, the other element, which is chlorine, and we make it chloride. Down here with barium, first part is as normal, and then oxygen becomes oxide. Then up here we've got lead nitrate. Now some students did, and I didn't mind either way, did put lead 2. So if you look up here, you'll see lead 2 has got a 2+ charge. We know that it's lead 2 because we had to have 2 nitrates. Nitrates are a 1- charge. Okay, so that told us that it was actually lead 2 because of the formula. But if you didn't put the Roman numerals 2 there, I was fine with that. So most students did pretty well in this one. All right, when we get down to here, this is something we're going to need to review. So this is where we're writing formulas. So we have to use our valency table to find our ions. I'm not going to be going back and forth, back and forth, back and forth, but I'm going to show you what they are on the worksheet. So I'll put the working here because we don't want to have any positive or negatives in our actual formula. We use them to work out our formula, but we don't include them in the formula. So lithium is 1+ and chloride is 1-. That is a 1-to-1 ratio That 1 plus will cancel out that 1 negative. So our formula is LiCl. Calcium is a 2 plus. Hydroxide is one of our molecule or polyatomic ions with an overall 1 minus charge. To make sure our positives and negatives are the same, I've got 2 positives but only 1 negative, so I need 2 lots of this hydroxide to cancel out those 2 positives. So I show that by putting a little 2 there to say I've got 2 lots of this hydroxide, but I only needed 1 calcium because that had my 2 plus prongs, but I needed 2 negative holes. Alright, magnesium nitrate. Magnesium is 2 plus. Nitrate again is one of those molecule ions, which you'll find on your valency table. It's got an overall negative 1 charge, which means I need 2 of them to hook up with the magnesium, which has 2 plus. So again, I put my magnesium nitrate, put it in brackets, and then I'm going to put a 2 there to say that I needed 2 lots of that to be able to plug into those pluses. All right. Now, sodium oxide. So sodium is a 1 plus and oxide is 2 minus. Okay, so this one is around the other way to these two. So I've got 1 plus and 2 minus. I need an extra plus to plug into that extra minus. The way I show that is Na2 oxide. And then finally iron 3 sulfate. So Fe3 plus. Sulfate is another one of those molecule ions. It's got a 2 minus overall charge. So I need to make these charges equal, and I can't just double one, because if I double this one, that's 4 minus, and that doesn't cancel out 3 plus. If I double 3 plus, that's 6 plus, but that doesn't cancel out that one. So what I need to do is go beyond 2. I need to double the iron, that'll give me 6 plus in total, and I need to triple the sulfate, which will give me 6 minus. 6 plus, 6 minus, that'll all plug in and make a nice neutral compound. So to show that I have 2 ions, I put a little 2 there. I put my sulfate molecule ion in brackets, and then I need to show that I've got 3 of it. Put a little 3 outside. Ta-da! So what we don't want to see in your formulas is this sort of stuff. Like paint on my fingernails. Alright, as in house paint. Moving on to balancing equations. So the first one was an easy one. The second one was less easy. I might do this in red. So the way that we work it is we put our in longhand. Now you can do it shorthand, that's fine. So we're going to list all of the elements. So hydrogen, chlorine, sodium, carbon and oxygen. Then we list those same ones in order without even looking at the other side, because we know that in a chemical reaction, whatever we started with, we'll finish with. We just might do a bit of a shuffle round. Then we're going to add up the number of atoms of each of those. So we have 1 hydrogen, 1 chlorine, we have 2 sodium, 1 carbon, and 3 oxygen. And over on this side we have 2 hydrogen, 1 chlorine, 1 sodium, 1 carbon. Now this is a trick because you have oxygen in 2 locations, so make sure you add them all up together. 1, 2, 3. So at the moment, hydrogen no, chlorine yes, sodium no, carbon yes, oxygen yes. So already you should be going, I need two sodiums here. So I'll find my sodium and I'll put a big 2 out the front. That will change my sodium, but it will also change my chlorine. So now I need to fix up my hydrogen and chlorine so that it's 2. I'll just pick hydrogen, find it, big 2. That'll change my hydrogen to 2. It'll also change my chlorine to 2, and balance, 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 balance. And that is balanced. Alright, now we'll do the same process. This one was a bit trickier because the oxygen number got big. So first thing, we list all of our elements. Barium, sulfur. So you've got oxygen here and there, but I'm only going to list it once. Aluminium, nitrogen. Now I'll go and list the same over here without even looking. Now I'm going to count them up. So barium, 1. Sulfur, 1. Oxygen, I've got 3 times 3 is 9, plus 4 is 13. Aluminium, 1. Nitrogen, brackets outside, 3 times 1 is 3. Over here, barium, 1. Sulfur, 3 times 1 is 3. Oxygen, 3 times 4 is 12. 2 times 3 is 6. 12 plus 6 is 18. This is where you could make an easy mistake and then you'll never get into it. 2 aluminiums, 1 nitrogen times 2 is 2. So if you are working on an equation it just doesn't seem to work, just start again, because it might mean that you've just made a little mistake in adding up initially, and if you're doing that it will never work because every time you change it, it will never get close to being right. Alright, so when I'm looking at this I'm not going to try and fix oxygen, it will fix itself because it is in every location. So every time I try and fix something else, oxygen will change, so it'll ultimately fix itself. I'm going to try and fix some easy ones. So I could fix sulfur by putting a 3 in front of the sulfur containing compound, so I'll do that. 3. So that was change my barium to 3. It changes my sulfur to 3. And it will also change my oxygen, so this is where I have to be careful. 3 times 3 is 9. Now you might want to just be like jotting little numbers up here as you're adding up. And 3 times 4 is 12. 12 plus 9 is 21. Alright, now let's go and fix something else. So I've changed barium to 3. Well, let's go and change barium to 3 over here. So big 3 over there. 3 barium. It's also changed my nitrogen. 2 times, so I've got 2 already, times 3 is 6. And it's also changed my oxygen. So I've got 2 times 3 is 6. Times 3 is 18. Plus I've got 12 over here. 18 plus 12 is 30. Okay, now I need to fix up something else. So I've got 2 aluminium, but only 1 over there. So I'm going to put a 2 in front of my aluminium containing compound. Change everything. 2 aluminium. My nitrogen, I've got 3 times 2 is 6. And you can see now that it's starting to come together. Now we just check our oxygens. So I've got 3 times 4 is 12, still over there. 3 times 3 is 9, times 2 is 18. 18 plus 12 is 30. 3, 3, 30, 2, 6. I would get rid of those little numbers that I use for working because they're not part of the balanced equation. And that is the hard one. Alright, finally, this one you could have written your answer just as a single answer. Lots of people just did it in parts, so we'll do it in parts. So, had to do the chemical formula of each reactant. So the reactants were sodium sulfate. So I'd be just using my valency tables. So I'll just, sodium is 1 plus. Sulfate is one of those molecule ions, 2 minus. So it's going to be Na, and I need 2 sodiums to address the 2 minus of the sulfate. Now if you put a bracket around there, that's okay. Then barium chloride. Barium is 2 plus, chloride is 1 minus. So I need 2 chlorides to cancel out the 2 pluses. So my other formula is BaCl2. All right, so you got 2 marks if you got those formula right. Then you had to work out write out the chemical equation for this reaction. So this is where you needed to show you understand a precipitate reaction. So Na2SO4 plus BaCl2 makes, and this is where we switch partners. So we take the front of one, we put it with the back of another, and then we take the front of the other and put it with the back of the other. Notice that I didn't take the 2 over to here, because that 2 is there because it's with barium. Same with the sodium, the 2 is there because it's with sulfate. We had to fix it because of the charges. So I left that 2 in that one, and I just took the actual element. Right, then I would check my formula. So barium is 2 plus, sulfate is 2 minus. That one's fine, 2 plus, 2 minus. And sodium is 1 plus, chloride is 1 minus, chlorine 1 minus. So that is fine as well. So you got 1 mark for the formula, 1 mark for the formula, and another mark for working out the front and back. So if you mucked up the formulas, but you got the front, like barium with sulfate and sodium with chloride, then you got a mark for that. Part C was balance the chemical equation. Okay, so I'm going to do it, actually going to do it shorthand because I've already explained it. And I'll show you just how I do it shorthand. I'll use a red pen. Now, you have to make sure you know what you're doing with shorthand, because when you do shorthand, you tend to group your molecule lines together, which can be tricky if the oxygen is located in multiple locations. I group them together if they're in a single location, but if oxygen was in here and here, and here and here, then I would just be counting oxygens on their own. So it's up to you, but like I said, if you're comfortable with balancing equations, then you'll be able to do this because you know what you're doing. If you're not, then do the longhand. What you'll see here, I've got, I do a little tick. Now you can do it in your head. Sulfate, 1 of those. I've got 1 here as well, little tick. Barium, 1, barium, 1. I've got 2 sodiums, but only 1 over here, so I'm going to put a 2 there. Tick that sodium, tick that sodium. Chlorine, I've got 2 over here, and now I've got 2 over here because I put a big 2. So now it's balanced. So you just needed 1, 2 in front of the NaCl. And then the final step was to identify the states using the solubility rules. Okay, so you had to put aqueous. Now you could have checked it. So all chlorides, except those exceptions, are soluble. So barium chloride is aqueous. All sulfates, except for those exceptions, which doesn't include sodium, are soluble. So Na2SO4 is aqueous. NaCl, so all chlorides we've already looked at, all soluble except for those exceptions. So NaCl is aqueous. And then barium sulfate, so sulfates, all are soluble except for barium sulfate. So barium sulfate should have got an S for solid, would have formed a precipitate. So you got half a mark for each of those states included in your equation, which totaled 2. Wow, 29 minutes of explanation. All right, so hopefully that has helped you for any questions that you've had problems with. Thanks for listening.